Hi everyone, this is to discuss the questions from Cambridge Pre-U for the topic Modulus. Let's look at the first question here. So we have the equation 3 plus 2x is equals to modulus of 7 minus 4x. So for this one, okay, what we need to do is we have got a single side which we have the modulus, and then we have another one which is no matter is a function or is a constant, so we can always use the definition of this modulus is that if we have modulus of modulus of x is equals to a, so we will actually have x is equals to a, or we actually have x is equals to negative a. So we can actually use this idea. So by looking at the question, we know that there is a modulus of 7 minus 4x. So we have to open up the 7 minus 4x. Okay, we have to open up the modulus. So what we have here is we have 7 minus 4x will be equals to 3 plus 2x. Okay, or we have 7 minus 4x is equals to negative of 3 plus 2x. So basically from there we just have to solve like usual. So for the first one, we will actually have 6x is equals to 4, where we have x is equals to 2 over 3 for the first one. And for the second one, just be careful of the negative sign. So the negative sign is for the 3 plus 2x. So just expand it, and we have to solve it carefully from there. So if we actually solve it carefully, we get x is equals to 5. So for this one, we actually have got two values of the x which satisfy the equation. Okay, so if we are actually not sure whether we have got the correct answer or not, we can always substitute this answer, okay, back into the equation, and we can always check whether we have the correct answer or not. But for this one, these two values of x would be the solution to this modulus equation. All right, next one. Solve the inequality where we have the modulus of 2x minus 1 is less than 3. So this one we have to use another property of the modulus, which we have, if we have modulus of x is less than a, so this means the x is in between positive and negative of the a. Okay, so we're actually using this property to solve. So if you look at the equation again, okay, we have got modulus of 2x minus 1 is less than 3. So in that case, we have 2x minus 1 will be less than 3 and more than a negative 3. So this 2x minus 1 is in between, okay, negative 3 and 3. So just have to manipulate this expression, and then we want the value for x only. So add 1 to all the terms. So we have negative 2, 2x, and a 4. So divide by 2 for all the terms, we have negative 1, x, 2. So in this case, the x is in between negative 1 and 2. So this will be the solution for the second question here. The third question here is we have got the function which is fx is equals to modulus of x minus 2 plus 3 when we have the x is in between negative 5 to 5 inclusive. So we need to sketch the graph for this y is equals to fx. So how do we actually do this is first let's just consider the graph for x minus 2, okay, when we have a modulus to it. So what we have for this x minus 2 with the modulus is that we actually have a line which is x minus 2. So x minus 2 has the gradient 1, and then we know that the y-intercept is a negative 2. So let's just draw the original curve first. So this will be the original line. Okay, and we also have the values, okay, that we have for x is equals to 5. So when x is equals to 5, okay, what we have for this y value is that we just have to substitute inside the y in this case. So we have 5 minus 2. So we actually get the 3 for our y. And remember what we need to do is we are going to reflect this. But before we actually reflect that, we need to find out what is the value of the y in this case when x is equals to negative 5. So when we have x is equals to negative 5, in this case, we have got y is equals to negative 5 minus 2 with the modulus. So we have the y is equals to 7. So we have to reflect this. Okay, so from the y-intercept, which is negative 2, we have got the 2, okay, as the intercept. So we have to reflect this. Okay, and we have to mark the value for the y when we have x is equals to -5. So in that case, our y is 7. Okay, so when you actually draw it, I think you should actually follow according to the scale. It actually looks nicer. So this is a graph for modulus of x minus 2. So what happened to the graph of the fx is that we have got, for this one is a modulus of x minus 2 plus 3. So from the transformation, okay, remember that when we have got this modulus of x minus 2 plus 3, it means that we have to move the whole graph, okay, up by 3 units, or it's a translation, okay, which we have the translation which is 0, 3. So from x minus 2 for the modulus, so it has to go through the translation which is 0, 3. So we move the graph, okay, up by 3 units. So what we have from there is we still have 2, okay, but now the graph starts at 3, and then the intercept would be 5 in this case, okay, and then we also have the highest value that we have got there is a 10. Okay, so we also need to remember that the x only goes from 5 to -5. So when we have x is equals to 5, okay, and we also have the x is equals to -5. So from there, we just have to move this whole graph, okay, up. Okay, by 3 units from there. So we have when x is equals to 5, the y is equals to a 6 now. So since we move the 3 here, okay, up by 3 units. Okay, so this is how the graph actually look like. Next one. So solve this inequality, okay, given giving the answer in exact form. So whenever we have two sides, no matter it's an equality or inequality, so if we have two sides, okay, they have modulus, so we can actually square both sides. Okay, so this doesn't apply to the equation or the inequality that only have one side, okay, which we'll look at it later. So for this kind of question, it is always safe to square both sides and solve it. Yeah, okay, and then we don't have to worry about the answer, whether it is valid or not. So because we have got two sides modulus, so it is always safe to square both sides. Okay, so what we need to do is we just need to square both sides for this one. Okay, we just have to square both sides, and then we actually have x squared minus 2 root 3x plus a 3 less than x squared plus 4 root 3x plus 12. So in this case, the x squared term will actually cancel off. So we only have -6 root 3, x is less than 9, and then just move the -6 root 3 to the other side. So remember, because we are dividing this, okay, by a negative number, so we have to switch the sign. Okay, so we have -3 over 2 root 3, which, okay, this can be also written as x is greater than -root 3 over 2. So we just have to rationalize this one, okay, in order for us to get -root 3 over 2. So this x is greater than -root 3 over 2 would be our solution. Okay, so let's look at the next one. So for this next one, we have got 5x plus 3 is less than modulus of 3x minus 1. So this is where we have to be careful when we actually solve this kind of inequality or the equality, because we only have one side, okay, which has the modulus. So by right, we shouldn't square both sides, okay, although we can actually square both sides, okay, we can actually see that square both sides also works, but we just have to do extra step to actually check. Okay, so here I provide a few ways for us that we can actually solve this equation. So the first one is by using the definition. So just now we have looked at the case where when we have modulus x is less than something, no matter it's a constant a or it's a function. So for this one, okay, what we need to do is we have now the case is, let's just flip the inequality over. So we have got a modulus of a function, no matter what is it, when it is greater than something, no matter it's a constant or it's a function. So if it is a constant, okay, it is very safe for us to just proceed with this with this step. But whenever we have a function, okay, we cannot just solve it like this. So there's an extra step that we have to be careful as well. So what we do here is, okay, this means we have got the x is less than negative a, or at the same time we also have the x is greater than a. So we can actually use this to actually solve it. So just consider this. We have got 3x minus 1 is less than, okay, negative of 5x plus 3. So this is what we have for this first part here. And then to apply this second part here, we have got 3x minus 1 is greater than 5x plus 3. So when we actually are trying to use this rule, right? So remember, it is less confusing if we use the plus and minus on the term which do not have the modulus. Okay, so we don't use the plus and the minus here, okay, at the term that has a modulus. It is very confusing. So always use the plus and minus term, okay, at this term, okay, or the side that do not have the modulus. Okay, so remember, this is the rule that we actually have to use. So from there, it's by solving it like usual. Okay, so for this one, it's not a difficult thing to do. So we'll actually end up with two inequalities, which we have x is less than negative 2, and we also have the x is less than 4. Okay, so less than negative 1 over 4 in this case. So for this one, okay, we have to check, okay, whether the value or the range that we have got here is correct or not. So we always have to check. So what is the method that we use for checking is just assign any random value, okay, which is related to these two values here. We have got negative 2 and negative 1 over 4. So what we can do is, okay, we can draw a number line, okay, to indicate where is the solution. So we just have to find out what are the values that falls in between like these three ranges. Okay, we'll just take any value which falls in this range here. So let's say we take x is equal to negative 3 here, and then let's just take x is equal to negative 1, and then here let's just take x is equal to 0. So what we need to do here is we substitute each of the value here to check whether the values here satisfy the inequality or not. So when x is equal to negative 3, okay, let's check the left hand side. The left hand side, we actually have a negative 12. The right hand side, okay, that we have is 10. So for this one, okay, we look at the sign here. The sign here is a less than. So the left hand side should be less than the right hand side. So for this one, the value works, okay, for x is equals to negative 3. So we do the same thing for the rest. When x is equals to negative 1, the left hand side is a negative 2. The right hand side is a 4. So again, the left hand side here is less than the right hand side. So it works. Okay. Let's just try for another value, which is x is equals to 0. So in this case, if we have x is equals to 0, the left hand side is a 3. The right hand side is a 0. So the value doesn't work here. So what we have for this case is we have got, for this range, it works. For this range, it works as well, but not for this range. So finally, the answer that we can actually conclude here is that x is less than negative 1 over 4. Okay, so this is the first way that we can actually consider. Okay, so of course, we have got another alternative, okay, is to just square both sides, okay, and then we just have to do the checking like what we have like just now. So by squaring both sides, okay, we have got 5x plus 3 squared less than 3x minus 1 squared. So we just have to square both sides from here. So what we have is we actually have 25x squared plus 30x plus a 9 is less than, okay, 9x squared minus 6x plus 1. So just have to tidy out a little bit. So we have got 16x squared and we have got 36x, and we also have plus 8 is less than 0. So for the whole equation, okay, we can simplify it a little bit first. So from there we can actually get 4x squared plus 9x plus 2 is less than 0. So for this one, we know we can actually factorize from there. Okay, so for that one, we can actually get 4x 1 and x 2. So for this, we get x plus 2, and then we have got a plus here. So for this one, okay, we can actually see that if we actually follow the to solve this quadratic inequality, we have got negative 1 over 4 and we have got a 2. Sorry, negative 2 and negative 1 over 4. So in that case, what we actually have is that we have this solution. Okay, but clearly what happened is that we do not have, the answer is not this one. So like, even though if we actually square both sides and we actually obtain like this inequality until here, we still cannot, okay, just simply use this method or any other method which is similar to this one to solve the quadratic inequality. Okay, so what we need to do is, because we see that we have got two important values here, we have got x is equals to negative 1 over 4 and also we have x is equals to negative 2. So in this case, we have to consider the method just now again. Remember, so we have to like choose 3 values and then we have to do the testing. So at last, if it actually gives us the solution where we have x is less than negative 1 over 4. Okay, so the idea for this one is get the important values, okay, where we have the 2 values, okay, usually. So just choose the number in between the 2 values and then substitute them, and then we check, okay, whether those values satisfy the equation or not. Then from there, we actually determine, okay, whether which inequality works, okay, for this equation. Okay, so this is another method. So for another method that we can actually use is we can actually use the definition for the modulus to solve, which is the most accurate. So if we actually learn this one, we can actually solve different types of the question. Okay, so this method is particularly useful when we have got this kind of the question where we have is an inequality and then we only have one side is a modulus. Okay, so let's look at the idea for this one. So we have got modulus of 3x minus 1 is greater than 5x plus 3. Okay, so this one, remember, we have to rely on the definition of the modulus. So okay, if you recall a little bit, what we have for this idea is that let's say we have the modulus of ax plus b. So it will actually take 2 values. So the first value is we will actually take the positive value for this one. If our ax plus b is a positive value, then we will take the positive value. If this ax plus b is a negative value itself, we will have to negative that negative value in order for us to always achieve, or we always get the positive value. So this is what we mean by the modulus. So we will actually have 2 kinds of the values. So how do we actually determine when do we take this value is that, so for the first case, the modulus of ax plus b will take the value of ax plus b when this whole thing, the ax plus b, is greater or equals to 0. So ax plus b is greater or equals to 0 when the x is greater or equals to negative b over a. Okay, so otherwise we will actually take the negative value of the ax plus b. Okay, so if you actually use this idea for 3x minus 1 with the modulus, we'll actually take 2 values. It could be 3x minus 1 itself or the negative of 3x minus 1. So we will take the value for the 3x minus 1 when we have x is greater or equals to 1 over 3. And then otherwise, we will actually take the value of the negative of 3x minus 1. So by using this, we can actually solve the equation. So is to consider like the ranges of the x first. So when we have x is greater or equals to 1 over 3, so we have the 3x minus 1, okay, would be the modulus 3x minus 1 will be this value is greater than 5x plus 3. Okay, so for this one, when we actually try to solve it, okay, we actually have x is less than negative 2. So in this case, there is no solution for this range. Okay, why do we say so? Is because we already mentioned that the x will actually takes the value which is greater or equals to 1 over 3. But when we actually say that x has these values, the solution that we get is x is less than or equals to negative 2. So basically these two ranges, they are not related at all. So for the first part, we do not have a real solution to it. So we have to look at another range where we have x is less than 1 over 3. So when x is less than 1 over 3, the modulus of 3x minus 1 will take the value of negative of 3x minus 1, which is greater than 5x plus 3. Okay, so when we actually try to solve this, the x is less than negative 1 over 4. So what is a conclusion to this one is that, okay, we say that the x is less than 1 over 3, and the values, okay, after we have solved it, okay, we will get the value of x which is less than negative 1 over 4. So for this one, we'll actually have the x is less than negative 1 over 4 as the solution. Okay, so at last, by considering different values of the x's here, so what we have, okay, at last is that we will only consider the x which is less than negative 1 over 4. Okay, so if we follow this idea by using the definition, we don't have to really do the values that we don't really have to do the testing of the values where we sub in the values in the different ranges and we compare the left and the right hand side and check their inequality. So if we use this method, it will be a bit more formal and it will be actually more accurate. Okay, so we don't have to worry we will actually make a mistake. Okay, so basically that's all the questions that I want to go through with you all. So I'll see you in another video.